Hello guys. So in this lecture we are going to talk about algorithms. Okay. So the first part of C++ STL, which was container, okay, is complete now. So now we are going to talk about algorithms. Okay. Algorithms. Okay. So these algorithms could be used in with the containers as well. Uh, you know to help us simplify the process. Okay, now let us see how we are going to work, okay, with algorithms. So there are certain functions within a library which is called algorithm, okay, which has the name algorithm. Okay, to include this library we must use this at the top of the C++ function, hash include algorithm. Okay, algorithm. So this is how we include the algorithm library, and then we can use certain functions. So what are these functions? So the first function is binary search. You have heard of binary search when we try to search an element in an array. But in case you haven't heard of it, you can check it out, on the documentations. Okay, so binary search helps us helps us to check whether a particular element exists in an array. Okay, whether a particular element, okay, exists in an array or not. Okay, in an array or not. Okay, it has to check whether an element exists in an array or not. Okay, uh, how this works? So let's suppose we have an array like this: 11, 12, 1, 5, 2. Okay, so the array must be sorted in order to perform binary search, right? So let's sort it. Okay, sort means the array is stores element in the form of ascending order. So 1, 2, 5, then 11, and then 12. Okay, now upon applying binary search, okay, upon using this binary search function, which is under the algorithmic library. Again I did this. Okay, so upon using this binary search function, uh, uh, we can check, okay, what is the syntax. So the syntax goes just like this: binary search, okay, start, then we give the end of the vector or array, and then the element that we need to search. Okay, to search, okay, the element we need to search, we put it at the end. Okay, so let's suppose we have a vector. Okay, in case of vector we have to give the iterator. Okay, so how it works? So binary search, okay, there is underscore, this is already in the definition only. Okay, so binary underscore search, then start of a vector will be v dot begin, in case we are working with vector. Okay, let's say vector has the name v. Okay, so v dot begin comma v dot end, and iterates the end of the vector. Okay, and to search, let's say we want to search for whether 5 exists or not. Okay, so this is going to return a boolean value 1, since 1 is present in the vector, right? Since 5 is sorry, not 1 actually, since 5 is present in the vector, so it is going to return 1 as the output. Okay, so if we print this, it is going to give us 1. Okay, so let me take you to the Visual Studio Code, and let's see if it works or not. Okay, so I told you that okay, let's create the program first. Algorithm.cpp. Now let's write the boilerplate code. Okay, so iostream. Okay, okay, uh, okay, okay. So let's include the library, algorithmic library. Okay, so hash include, we'll write hash include, then algorithm. Okay, algorithm. Okay, now if you want it to, now if you want to work with this library, if you want to use binary search function, so to use binary, let's say we have a vector. Okay, vector int v, okay, of data type int. Okay, now it is having the value 1, 2, 5, 7, and then 9. Okay, now if we want to search whether this okay, to work with vector we also need to include vector library of vector, right? So hash include, we will, let's say we have to include vector library. Okay, so vector library included. Now let's try to use binary search. Okay, so upon, if we try to print the output of binary search, okay, binary search, uh, let's say v dot begin, okay, start, end, end should be v dot end of the vector, and let's say we want to search whether 2 exists or not. Okay, so the output should be 1. Okay, let's see what is the output. Okay, so terminal. Okay, so the output is 1 here because 2 exist in the array. Let's check for 3. Okay, 3 do not exist in the array, so let's see, the output should be 0. Yeah, so the output is 0. Hence this is how the binary search function works. The array should be sorted. Okay, in this case I have taken the sorted array. If in case you do not have a sorted array, I'll tell you another function by which you can sort the array. Okay, now let's get back to the to the screen. Now let's add new page. Okay, other functions than the binary search are the first thing we can do is we can find the min max between the two values. Okay, we can use swap and sort functions. Okay, this sort function will help in sorting either the array, okay, or it can help in sorting the vector. Okay, we can do swap sort. Swap means it has to swap two values. Okay, swap two values. Okay, then we have fourth thing that we can do is lower and upper bound. Okay, lower and upper bound is related to binary search only. Okay, so now let me tell you okay, one more thing. The last thing that we can do using this algorithmic library is reverse and rotate. Okay, reverse and rotate. So by rotate, we can rotate the array by I places. Okay, rotate the array. Okay, and reverse means we can change, we can completely reverse the array. Let's say we had an array 1 2 3 4 5. By using reverse, we will get 5 4 3 2 1 as the reversed array. Okay, now through rotate, let's say we want to rotate this 1 2 3 4 5. Okay, by 2 places to the right. Okay, then 3 will come at the front. 3 4 5 1 and 2 it becomes. Okay, now let's let's see how it works. Okay, all of this, but first we'll go to lower and upper bound. Okay, now let's check how lower and upper bound work. Okay, so we got to know about binary search. You can store the result in a boolean variable as well. Okay, bool b is equals to this, and then you can print it. Okay, like this. Okay, yeah, so if you try to print this, it will give us 0 because 3 do not exist in this particular vector. Okay, now let us check how lower and upper bound work. Okay, so let's move to the next page. Okay, so lower and upper bound. Lower bound gives lower underscore bound. Okay, it is written this way, lower underscore bound. Then we give start, we give end, and then we give the element. Okay, element of which we have to find the lower bound. So lower bound gives the small largest value which is smaller than or equal to the element. If the element exists itself, then it will give the value of the element, but if it do not exist, then the element which has a smaller value than this particular element will be output. Okay, let's suppose we have an array 1 2 5 7 9, and we want to find the lower bound of an element. Okay, let's say the element is 6. Okay, 6 do not exist in the array. Okay, so the lower bound will be the largest value which is smaller than. Okay, because equal to do not exist, so smaller than is 5. Okay, the largest, and it is the largest as well. 2 is also smaller than 6, but it is not the largest, right? So the largest is 5, therefore the lower bound will give us 5. Okay, in this case. Now if we try to find the lower bound of an element which exists, okay, lower bound of 7, we don't write it this way. Okay, the syntax is this. Okay, so we'll write it this way only. Start is in case of vector it is v dot begin, in case of array it is the name of the array simply, and end will be a plus n in case of array. In case of vector, start is v dot begin, okay, and end is going to be v dot end. Okay, this way, if v is the name of the array. If a is the name of the if v is the name of the vector. If a is the name of the array, a and a plus n will be the start and end. Okay, and n should be defined as the size of the array. Okay, now lower bound of 7, this is just for the explanation purpose. So lower bound of 7, 7 is already present, so it will give 7 only. Okay, if 7 was not present, then it would have given 5. Okay, Yeah, so let's check this thing. Okay, and before checking, let's also talk about the upper bound. Okay, upper bound. Now let's check what this upper bound does. The syntax of the upper bound would be, okay, let's move it. So the syntax would be upper underscore bound, okay, start and element of which we have to find the upper bound. Okay, so what upper bound gives? Okay, upper bound gives the smallest value which is greater than element. Okay, smallest value which is greater than element. What I mean by this is, let's say we have an array 11, 15, 17, 22, 55. Okay, this is the sorted array. Okay, we perform this on the sorted array only. So let's say we try to find uh, we try to find we you know we want to find upper bound of 15. So there exists an element 17 which is the smallest and yet greater than the element. Okay, 22 is also greater than element, but it is not the smallest, right? 17 is the smallest, so 17, it will give us output as 17. Okay, now in case we want to find upper bound of 11. Okay, so what is the smallest value which is greater than element? 15 is the smallest value. 17 is also greater than element, but it is not smallest, right? 15 is the smallest, so 15 will be the output. Let's see how it works. Okay, let me take you to the Visual Studio Code and let's try to use this upper bound and lower bound on this thing only. Okay, so yeah, let's try to use upper bound. Okay, so upon printing the lower bound first, lower bound of this is vector, so v dot begin will point to start, v dot end points to end, and the element, let's say I want to find the lower bound of 3. So 3 do not exist in the vector, right? What is wrong, let's see. Okay, I don't know what is wrong with this. Let's try to review this. Okay, it gives error. Okay, let's try to see why is it giving an error. uh, is there anything wrong? I should not use this cout, I think. Yeah, so let's see. Okay, bool b1. Okay. But it could be printed using this cout. Okay, I think there is some problem. Let's try to. Okay, it won't give anything. So, oh, actually I did a mistake here. So I must, in case of vector, I must reduce v dot begin iterator so that it gives the value. Okay, either I write it like this to give the value. Okay, this will give the iterator and not the value itself. This won't. Okay, so I want to correct this thing. So lower bound. Okay, let me go back. Okay, so lower bound will give iterator to iterator. Okay, iterator is similar to pointer. Okay, so it will give a pointer to this value. If you want to find the lower bound of 6, it would give us a pointer to 5. Okay, it will give us pointer to 5. Upon dereferencing it, we'll get the value. Okay, either we dereference it this way by putting a star in front of it, or we dereference it by reducing v dot begin from it. Okay, there are two ways. Okay, so either you write it this way. Okay, either you write it this way, or you can let's see what output we get. So we get 2, right? It gives the index. Okay, so 2 is the index, right? If we try to, sorry, let's check. So we wanted to find the lower bound. Okay, so the smallest value which is greater than, or yeah, so it gives 2. Let's see for the value 6. Okay, so for 6 what we get. Yeah, so we get 3. Why 3? Because the largest value which is less than or equal to which is less than 6 is obviously 5, and they are not equal. Okay, so 5 is at third place, so that's why I get 3 as the answer. So we do not get we don't get index, rather an iterator. Okay, and if we dereference it, we get the value. Okay, so 3. Now let's see, no, let's take 6. Okay, still we are going to get 3 only. Yeah, so we are getting 3. Let's take 7. In this case we are going to get 4. Okay, because equal to, oh, what is, okay, so I put it here, I should implement it here. Okay, so now let's see what we get. What's wrong, what's wrong? uh, so let's try to, okay, so I was changing value here, I guess I should have changed the value here. So let's say I try to, okay, I try to put the value 5 here. In this case, what do I get? I get the value 2. Why 2? Because the index of 5 is 2, right? If I try to put let's say 4 here, I'll get 1 because the index of 2 is 1. Why is it not working correctly, man? Let's see. Okay, so let me try to understand a little bit. So I was a little wrong here. Let's get back to the screen and let's talk about it. Okay, so the definition of upper bound is correct. Okay, but the definition of lower bound is something we got wrong. Okay, so lower bound, okay, the syntax is the same. Okay, start, end, and the element. Okay, but what lower bound does is that it gives the value, okay, the value which, the first value, okay, first value, I must write this, first value which is greater, which is greater than or equal to the element, okay, that we have passed in the lower bound function. Okay, it gives this value. Okay, if we find the element itself, then it will give the element, but in case we don't find the element, it will give the first value which is larger than element. Okay, let's see what I'm talking about. So let's suppose we have an array 1 2 3 4 and 5. Okay, so if I try to find lower bound of uh, and not even element, it will give the iterator, or we can say pointer. Okay, so we have to dereference the pointer in order to get the value. Okay, uh, so lower bound of 4 gives us 4 only, because 4 exists in the array, right? So it will give us 4. Okay, the first element which is either equal to or greater than the element. Okay, if we find equal to, we do not need to go on the greater element, so it will give a pointer to this element. Okay, and if we try to dereference this pointer, we will get the we'll get the index. So it is at index 3, so we'll get 3 as the output. Let's check. Okay, let's check this thing. So now let's get back to the Visual Studio Code. Okay, now let's see. So this is the array 1 2 5. This is the vector, sorry, this is the vector. We have declared the vector as 1 2 5 7 9. Now we are trying to find the lower bound of 4. So 4 do not exist in the array, so we are going to get the first value which is greater than 4, which is 5. Obviously 7 is also greater, but this is not the smallest element which is greater than the element that we have passed in the lower bound function. So let's try to run. So the, upon, this is used for dereferencing purposes, minus v dot begin. Okay, either you dereference it this way, or either you put a star in front of it. Okay, so I'm dereferencing it this way. Now if I try to print, let's see what is the output. Okay, so let's clear the terminal first. Okay, and let's try to run this. Okay, so I'm getting the output as 2, because the index of 5 is 2. Okay, 0 1 2. Okay, now let's try to find the lower bound of 5. We'll get 2 only, because 5 is already present. Now let's find the lower bound of 6. We'll get 4. Okay, sorry, 3, because the index of 7 is 3. Yeah, so this is how the lower bound work. Okay, now let's talk about the upper bound. Okay, so how upper bound work? I have already told you that the definition, that it will give the give the iterator to the first element which is greater than the element, okay, element itself. So let's talk about the upper bound. So first element is 1 2 5 7 9. If we try to find the upper bound upper bound of, let's say, 5, okay, so it will give first, it will give the element which is greater than, or which is greater than 5, okay. So it will give iterator to this element, okay, 7, okay. And upon dereferencing it, we get, so the index is, of 1 is 0 1 2 and 3, so we'll get 3, okay. Let's take this example, okay, 1 2 5 7 9, okay. Yeah, so the vector is already like this. Now let's try to find the upper bound, okay. Let's remove this, see out, upper underscore bound, okay, bound. Now v dot begin, okay, v dot end, okay. And now let's say we try to find the upper bound of 5, okay. Okay, so upper bound of 5 will point to this 7, and if we try to dereference it, okay, yeah, so now let's see what we get. So we are getting 3 because the index of 7 is 3, okay. We can also dereference it this way. We remove this, we put this inside parenthesis, this upper bound function, and then we put a star in front of it, okay, this way. Yeah, so now if we try to print it, it will give us 3 only, okay. It will give us element, okay, sorry, so I was again wrong. So in this case, it gives the element, okay. If we try to dereference it this way, it will give us element, and this way it gives the index, okay, minus p dot begin, okay. Yeah, this way it gives the index. Yeah, so this is all about, lower and upper bound. Now the next thing that we are going to talk about is swap and sort, okay. So let's talk about swap and sort. Let's comment this out. So what swap does, let's suppose we have two variables, okay, int a is equals to 5, let's say we have another variable b is equals to 10, okay. Now we want to swap the values of these two variables. We want a to be 10 and b to be 5, okay. So we will use simply swap, okay, and then we'll use a and b, we'll put both the variables inside it, and this is how this swap function is called. Now upon executing it, let's try to print the values thereafter, okay. Let's see out, okay. So value, okay, value of a, okay, let's try to print a, and let's see what it gives us the value, okay. Yeah, so we assigned the value to a as 5, but after swapping we get the value of a to be 10, right? So this is how swapping works. Same in the case of b. So let's say we try to print b here, we'll get 5 as the result, okay. Let's see. Yeah, so we are getting 5 as the result, right? So this is how swap function works, okay. So sort is used, now sort function is used to sort a particular array or vector which is not sorted earlier, okay. Let's suppose we have an array, okay. So int arr, okay, let's say the name of array is arr. Let's say we have let's say we have 11 12 4 3 4 1 0, okay. Now we want to sort this. Sort means to keep the elements in the ascending order, okay. So what we'll do, sort, then we'll give the start of the array. Start of the array is a, and end of the array is a plus n, okay. We haven't declared n till now, so we have to declare n, right? So we assign it the value size of, okay, arr divided by size of arr 0, okay. This would give us the size of the array, which is 5, obviously, okay. So now let's try to, okay, wait, so let's clear this, okay. Okay, so a was already defined as the variable, okay. Let's erase this as well. So now let's try to, okay, so this should be arr, not arr, okay, because the name of the array is arr, right? Now let's try to execute this. Okay, we won't get anything because we haven't tried to print the array thereafter. So let's try to print the array, okay. We can print the array like this. For int I equals to, using the for loop, 0, the index of the array goes till 4, okay. So 0 1 2 3 and 4, so we'll put less than equals to 4 because it goes till 4, right? 4 is also a valid index, I plus plus, okay, each time. and each time we try to print ARR of I. Okay, now let's see what is the array after sorting. Okay, this is after sorting. Okay, comment after sorting the array becomes. Let's see the array after sort. So 0 1 3 4 12, this is what we get as the output. Okay, so this is completely sorted, right? These elements are placed in the form of ascending order. So this is how we can use sort function. Now what we are left with is min max function. Okay, we can use min max function. So let's suppose let's try to comment this. Okay, let's suppose we have int a is equals to 5, okay, 6, and let's say we have b is equals to 3. Okay, now we want to find which one of them is the maximum. So we can use max function a comma b, and we can use endl here. Similarly, to print the minimum, we can use min function here, a comma b, and then endl. Okay, this is how it works. Let's see. So the maximum is 6 and the minimum is 3. Okay, now max min function could be used like this. We are done with swap sort, we are done with lower bound. Now the final thing that we are left with is reverse rotate. Okay, so how do we use reverse and rotate? So let's suppose we have an array in tr. Let's suppose we assume the same array. Okay, yeah, so this one, let's suppose we have this array. Remove this from there. Okay, let's comment this. Okay, let's try to, okay, yeah, so we have this array. Okay, now we want to reverse the array. Okay, so the array is 12 3 4 1 0. Upon reversing, it will become 0 comes at the front, then at the second place 1 comes, 4 at the third place, 3 at the fourth place, and 12 at the fifth place. So how do we do this? So the syntax, okay, let's get back to the screen. Let's add another page. Okay, so the syntax of reverse function is reverse. Okay, reverse ARR, the name of the array, the start of the array, the end of the array, ARR plus n. Okay, this is how we reverse it. Okay, and we do not, okay, we just call the function. Okay, let's see. So reverse, okay, ARR, since the name of the array is ARR plus n. Okay, ARR plus n. Okay, yeah, so let's try to print the array again. Okay, so for int I equals to 0, I is less than or equals to 4, because we can write n here as well, since n is the size of the array, right? And since it will be 1 greater, I'll write smaller than sign. Okay, cout, okay, ARR of I and L. Okay, let's see. Let's not put endl here, let's put a space. Okay, so that they get printed in one line only. Let's comment this. Okay, let's see. Yeah, so we get the array as 0 1 4 3 12. Okay, why we get this way? The array is completely reversed. So 0 becomes first, 1 becomes second, 4 becomes third, 3 becomes fourth, and 12 becomes the fifth element. Yeah, so this is what reverse function does. Okay, now let's clear this out. Okay, now let's try to rotate. Okay, so the syntax of rotate function is, rotate start, okay, start, mid, end. Okay, this mid will be something like it will be an iterator to a mid element. Okay, so the element to which it iterate, that particular element becomes the first element, okay, of the rotated array. Now what I'm talking about, let's see. Okay, so let's say I give it like this. Okay, rotate ARR plus let's say ARR plus 2, and then ARR plus n. Okay, now let's see what we get as the output. So the element at index 2, which is 4, becomes the first element. Okay, so 4 1 0 and 12 3, 4 1 0 12 3 is the output. 4 1 0 12 3 is the output. So this is how rotate function works. Okay, so yeah, this was all about the algorithms. Yeah, so we are done with this. Okay, algorithms part. That's it for this video. Hope to see you in the next one.